Hello, this is Emad Mirabi. I want to solve two questions about techniques of integration from Calculus 1, University Calculus 1. And I will solve and explain the way we do these integrations. Okay, so as you see, this is an indeterminate integral, which is the antiderivative. So we need to find the antiderivative of this integral, tangent cubed secant 4 of x dx. We know that if the derivative of tangent of x is 1 plus tangent squared, and from trigonometric identities this is equal to 1 over cosine squared, and this is secant squared of x. So based on this, we know that if we have every function of tangent of x, and then we have a tangent squared here, we can solve this by this substitution. If we take u as tangent of x, this integral will be integral of f of u du. So this is easier to solve. This is very easy because it will be quite algebraic. And in here, so this technique is applicable here. So we can make 1 secant squared. So this is tangent cubed, and I separate the tangent fourth of x to secant fourth of x into secant squared times secant squared, and then I can write 1 of this secant squared. I can substitute tangent squared plus 1. So it will be tangent cubed times tangent squared plus 1 times secant squared dx. So integral is like this: tangent fifth of x plus tangent cube of x secant squared dx. So if we apply the substitution of u, if we take u as tangent of x, the integral is u5 plus u3 du, which will be u6 over 6 plus u4 over 4 plus u4 over 4. So the answer of this will be tangent of x to the 6th square to the 6th power over 6 plus tangent of x to the 4th power over 4. This is the antiderivative of tangent cubed times secant fourth. So let's do another one. In here again, antiderivative is asked, which is an indeterminate integral. So if we go forward by applying the integrand by radical 1 plus x, which is the conjugate of the denominator, we'll have an integral of 1 plus x over radical 1 minus x squared. Here we can apply the trigonometric substitution. For example, I can take x to be sine of theta, because x is because here domain of x must be between -1 and 1, so we can take x as sine of theta, and then the x will be cosine of theta d theta. And so rewriting this in terms of theta, we'll have 1 plus sine of theta over radical 1 minus sine squared is cosine squared, and the radical is cosine, and then times cosine of theta d theta. Of course, these will be cancelled. Integral of 1 will be theta. Integral of sine will be negative cosine. Now, going back to the original variable x, we can write theta as sine inverse of x, or arc sine of x, minus, if the sine of theta is x, what is cosine of theta? Cosine of theta is radical 1 minus x squared. Okay, so this is the result of the final answer of this integral equation. This is the final answer of this integral, which is the antiderivative of this, function, the function given. Okay, I just meant to solve some questions about techniques of integration. That's it.